right, so I am going to talk to you a little bit about secant and cosecant graphs and how you actually create those. So let's refresh our memory about a few things. So remember that cosecant is the reciprocal of sine, and our secant graphs are going to be a reciprocal graph of the cosine curve. That's important because basically anything we know about properties about our sine and cosine graphs, we are also going to know about our secant and cosecant graphs. In other words, the period for secant and cosecant graphs, our basic period, is going to be 2 pi. So to begin with, our most basic secant and cosecant graphs without any changes are going to involve our basic x-axis markers, and you know those as our pi over 2, our pi, our 3 pi over 2, and our 2 pi, because that's our basic period, and we're still breaking this up into 4 equal parts. Okay, so we've got, if you notice, I've got some grids already drawn in there for these particular graphs to help us draw these. So for our cosecant graph, we know it's the reciprocal, of sine. So actually what we're going to do, well, let's go ahead and label marks first. So we've got pi over 2, and pi, and 3 pi over 2, and 2 pi. And I am going to just lightly sketch in what the graph of sine looks like, because we actually use that graph to kind of help us see. So I'm using a really light color here. It's going to help us see and visualize where we have to draw our cosecant graph. So because it's a reciprocal, if you think about different x and y values, if you think about what the y values are, and we basically take the reciprocal of them, that's going to give us an idea also of what the graph looks like. So as an example, if you think about it, we've got y values here that are very small, just right past the origin. So those y values are very small. Those are fractions. So I want you to think about this. If y is equal to 1/4, or y is equal to 1/3, or y is equal to 1/2. Now this is for our sine graph. So as we're progressing and getting closer and closer and closer to 1, our fractions will get bigger. But think about what kinds of values we get if we were to take the reciprocal of those. So if we were to take the reciprocal of 1/4, we get 4. If we take the reciprocal of 1/3, we get 3. If we take the reciprocal of 1/2, we get 2. So keep that in mind when we are graphing these, okay? All right, so when we draw in that, once we've drawn in that basic sine curve, we're going to have to look at and consider where this graph is crossing the x-axis. So I need you to think about the fact that it's crossing here and here and here. So at x is equal to 0, at x is equal to pi, and at x is equal to 2 pi. So that's important because if you think about it, if we take the reciprocal of those values, if we take the reciprocal of 0, then we get 1/0, and we know that that is undefined. So anywhere where that sine curve crosses our x-axis, we know we have an asymptote. So we have an asymptote at x is equal to 0. We have an asymptote. Now this is for our basic cosecant graph. We have an asymptote at x equals pi, and then we also have an asymptote at x equals 2 pi. Okay, so those are special values that you've got to label on your graph is where the asymptotes are, and you've got to draw in those lines. And then basically we use our sine curve, our lightly drawn in sine curve, to help us actually draw these points, draw in the shape of the graph. So we have this critical point here, I refer to it as a critical point here at pi over 2 and 1. We know that particular point If we take the reciprocal of 1, we're just going to get 1. If we take the reciprocal of -1, we're going to get -1. But because of this information here of how this is flipping, yikes, this information here of how these graphs flip, I want you to think about the fact that what that's telling us then is these values, to create our cosecant graph, we're actually just going to draw, we're going to reflect basically the shape of our sine curve here. So we are reflecting this shape, and you can't quite see that, so let me change colors. We're going to reflect the shape of this curve here, and we reflect it going up, and then basically our graph just continues until we reach these asymptotes. So we draw the shape of the curve going, reflecting this shape, going up. I'm going to erase this now so that we are, and then similarly reflecting the shape on the other side and going up, and the asymptotes tell us it's approaching there, but it's never going to cross there. So that gives us the shape of that curve on that interval. And then on this interval, if you think about reflecting the lightly drawn in sine curve, then once again we basically get another cup or parabola shape, that curved shape approaching these asymptotes. So that's our basic sine graph. Cosecant graph, the reciprocal of sine. So I want you to think about the secant graph. It's going to be a little bit different in its look, because if you think about it, as you know, I've got to get rid of that. That's going to bug me. We know that the secant graph is the reciprocal of cosine. So our intervals are a little bit different, where stuff crosses, etc., that type of thing. We're still going to have our basic x-axis markers. So pi over 2 and pi, and 3 pi over 2 and 2 pi. And let's lightly draw in our cosine curve. It looks something like that. All right, so let's actually draw in the curve now. First thing we've got to do, though, is draw in, if you notice, once again, we are looking at where these graphs are crossing the x-axis, where the y value is equal to 0, because when we flip that, when we take the reciprocal of that, we get undefined. In other words, there's where our asymptotes are. So on a secant graph, on our basic secant graph, our asymptotes are at pi over 2, and at x is equal to 3 pi over 2. If you notice what I find on these particular graphs, my suggestion is that you look at pi first, and you take that particular point and flip it. That helps you get a good look at what that shape is. On these other intervals, basically our other asymptote is over here at negative pi over 2. And then this one goes off the graph, basically, down way over here. So for me personally, what I find is a lot of students have trouble with this, and they kind of draw this curve incorrectly because they can't visualize the whole thing. So my suggestion is, although you better draw it better than I just did, draw in the whole curve. Sorry, I bumped my elbow here. So draw in the whole curve so that you actually get a good idea of what this part should look like. If you just want to draw the one part, then that's the left branch of the asymptote, of the curve, and this is the right branch here. So you can, if you want, to just show those two particular parts, but I do think that it is helpful to draw the full curve just so that you draw it incorrectly. Otherwise, people mistakenly draw it a little bit funky or a little bit different. So I would like to show you two other examples so that you are thinking about the fact that we're not going to have just our basic secant and cosecant graphs. We're going to have changes, just as we had changes to our graphs for sine and cosine. Same changes that we have for those, we could have for our secant and our cosecant graphs. So I want to show you just a quick amplitude first, and then if you notice I've got an amplitude change, and I've changed this from the note, so notice I've put a phase shift in there also, just so that you can think about that process. All right? Okay, so for a 2 cosecant, think about if we were to draw y is equal to 2 sine x, so the difference there, we're still going to have our basic x-axis markers, our pi over 2 and pi, and 3 pi over 2 and 2 pi. But for a 2 sine graph, we're going to be going up to 2. Let me draw this in that lighter color again, just to help you visualize, so we're not too focused on that graph when we're drawing our other one. But once again, we are going to find where this particular graph is crossing the x-axis, and that's where our asymptotes go. So x is equal to 0, x is equal to pi, and x is equal to 2 pi. And then we are looking for basically those critical points in the interval in between those asymptotes. So a critical point here, and we reflect the curve, and critical point here at 3 pi over 2, and we reflect that curve. So if you think about it, the amplitude change is just changing where these values start. So I want you to think about this. The range for these graphs was from negative infinity to -1, and then from +1 up to positive infinity. So that's the range for our basic graphs. If you think about this one, our range is going to be from negative infinity to -2, and then from 2 up to positive infinity. So the amplitude change adjusts what our range will be, obviously. All right, let's take a look at this last one. And we're drawing a -1/2 secant, and then we're doing this x plus pi over 6. So we've got to deal with that plus pi over 6 first. And I want you to think about that. That means we are going to have a negative pi over 6 here. And I'm going to pause and write in the rest of this, just a sec. All right, so let's draw in these hash marks. Excuse me, take a look at the math that I did there to get those numbers. Those should look somewhat familiar to you. We've had similar values before. 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 5. So let me label my x-axis markers. So pi over 3, 5 pi over 6, 4 pi over 3, and then 11 pi over 6. All right, so then we need to draw in our -1/2 cosine. So that would mean that we would be at -1/2, at 0, at +1/2, at 0, at -1/2. So that is what that basic graph would look like. And the -1/2 cosine, excuse me. And so now we need to, I'm going to change colors here, and I'm going to draw in my asymptotes again. So in this case, asymptotes at x equals pi over 3, and at x equals 4 pi over 3. So think about and notice asymptotes will change values if you have a phase shift or an amplitude change. And then we're drawing from that critical point, we're going to draw the shape of that curve. From this critical point, we'll draw the shape of this curve. And from this critical point, we'll draw the shape of this reflected curve as well. All right, so now you've learned two new graphs, secant and cosecant.